With the water company here, I'm going to explain your plumbing system. Obviously you've got city water going to the house, and then we've got this rainwater collection system. And in the system, just so you know, water comes down here first. You would think this is the path. Nope, that's a first flush. You can see it's got a plug there. Ideally that would be unscrewed a little bit, or it's got a, well, you got a hose bib right there too. So you can let some of the water out, and all the nasty stuff on the roof will first come out of here. It'll settle in here, and then as this fills up, then the water, as it keeps going, has to go down this way. So all of your downspouts have that. I actually like to do a first flush at the tanks right before it dumps in, then the nasty stuff from all of the downspouts gets flushed out. But this is another way to do it. It's not bad. Of these two boxes, which is interesting because it's a 200 amp meter, really should be a 320 to feed two 200 amp services, but might have just been getting more power. Anyway, neither here nor there. You've got your, right here, this top breaker is actually just 20 amp 120 going to the well house. That's going to turn on and off your irrigation system, but also your booster pump. We should add a disconnect inside the well house so we could turn on and off the booster pump right inside there. But this is how it is right now. Now you can see I've already turned this on. This is the well. I'm going to turn this on now, and we're going to go over to the well house. Take a look at that. But that's all I needed to show you there. Now, as we work our way this way, I'll explain what I did with the rain system, or the well system. The well pump was not running because the guys that were here didn't understand how a relay works. I've got a video on that. I'll send you the link to it also. You can find it on my YouTube channel. But the relay is in here. So when I turn that power onto the well, the power goes in. Now this is upside down, you see. So imagine the top is actually the bottom. You know, if I rotate the camera, where the words look the way you should be, that's the input. So you got power coming in from that breaker, then it goes out through the bottom. It only goes out if both sides of this are energized. So one side is naturally energized because I just got it looping through, but this other side, it goes out, it sends the power signal to a float in the pump, and that, or in the tank, the rain tank, and that float was bad, so it was not returning the signal here. When the signal returns here, now you have energy on this side of the coil, that side of the coil, it sucks in, and that allows, that's like turning a light switch on. Power's going to here to the light switch all the time, but once those sides of the coils are both energized, whether it be a 120, then it's hot and neutral, or 240, it's hot and hot, it sucks in the coil, and then it sends the power through the bottom. Now it's going through that power on the bottom into this well box, and it's just those two left, red and black, those are your leg 1, leg 2, sends power through those. As long as all the other parts and pieces in there are working, which they are, because it's working. Your capacitors, your run capacitor, your start capacitor, they're working. If they weren't, maybe we'd get some overload. Maybe we wouldn't get any power going through it. But we know that it's on. We can walk over here. And the guys that installed this system at first were really good. The guys that were here recently, not so much. But the guys were overthinkers that installed this, and I love it. So what they did is they come up through here. Now here's the well fill line. So it's going out from the pump in the ground all the way through here, and is going up here into here. Now when it's winter time, you want to be careful with this. You got to have this protected. And this, what I would do is I would put a T here, T off, and put a hose bib or a ball valve or something just to let the water out of this vertical line, and then turn the well pump off. If this thing's got enough water, or if you're not running irrigation, since that's all this runs, I would turn the breaker off to the well, which we saw in that first panel, and it's labeled well, and then I would open up the valve right here on the T that you put in here. This looks like it's an 1.25 inch line, so you get an 1.25 inch T and then a ball valve sticking off of there, and open that up. That way you bleed off all the water that's in this vertical section of line. And then of course, it's because of gravity, any part of this pipe that's above hill from here is also going to come out. That's going to protect this pipe. You don't have standing water in this pipe to freeze. You want to do that in your rainwater collection too. Put a T right here or put it down here. This is 4-inch, this is 3-inch down here. I would dig it down. Let's see, that's the end of a pipe. It's weird. It's kind of, oh, that's a bell housing. That's a flared out end. So don't cut it here. You won't find something that size. You would need to cut it here. So because of that, I would just say protect this bottom section, maybe put some dirt around it, put a T right here. Now you're bleeding off this vertical section, and anything gravitationally from there to here, it's gonna level out with the horizon, so to speak. So anything that's level with the output of this T upstream, that's all going to be bled out of water, because it's going to equalize, just like these two tanks equalize. Just because this and that are connected, and it's not a vapor lock, it's not an airtight seal. Air can come and go, and so as this water, if this tank, let's say, was full all the way, because you have this valve off and this is on, as soon as you open this valve, since these are connected, this water is going to go down until these two with gravity equalize, because it can displace in here that water with air through the venting, and same thing here. So that equalizes. That's what gravity does for us. Now the well is going to be intermittent. I hear it right now, splish splashing. You don't have a pump saver on that well pump. I didn't know it until right now, so I'm discovering this in real time just like you. But I don't hear it showering. Oh, I got the microphone on my shirt. Let me see if you can hear this. You can hear it you can kind of hear it showering in there. It's been running now for about 20 minutes, and it sounded like a real good shower in there until I got here right now. Now it's kind of spitting, which means the ground is recharging slowly, and that's not great. You need a pump saver on there so you don't have to replace that pump real soon, because it's just going to keep doing that, running and spitting out a little bit of water. Eventually that's going to run dry and burn out your pump. You have to pull all the pipe up from the ground. So that's that. Now this line right here, this is the electrical side. We talked about that relay a couple minutes ago. When I'm sending that one side from the top of that relay, it's going up through here, and it's going to a float that was bad. And that float has a weight, and then a float, and that goes like this. And you'll see the other video about that, so we don't need to talk about that, but that float was bad. The other float on the bottom was to protect your booster pump. They had taken off that pump safety low pressure cutoff arm switch, pressure switch, and then that left your pump unprotected. However, the guys that I really like that did this, they ran not only 2 wires in here for the send and the return of the fill float, but also one down at the bottom that's always on. And so I'm sending power to that one, and if it ever gets low on water, it will interrupt that power from coming back to that booster pump. So even if the irrigation control opens up the irrigation master valve and lets that pressurized water through the system, and that lowers the pressure at the pressure switch, and it says, hey, let's go ahead and run the irrigation pump, it's not going to run if that low water float goes down. And so now you had the wires in there and it wasn't in service. I just put it in service, and so that's the right way to protect it on an irrigation system. So I'm very happy that they had that. That made things easy. Otherwise I was going to recommend that we put one from there to here, and you have a fence line, so we could have just done it there. Now I've put this thing out of service. This is a John D. It's like a pool valve. I think that they had this in with the overthinking of things, and that's not bad. They just really tried to think of everything, right? So these wires right here go to that valve. That's like a selector valve. So what happens is you got power coming here to this transformer. Typically it's plugged in here into that outlet, which is hot. I have it disconnected. There's a float in here, in this tank. That could have been in either tank. It doesn't matter because they're equalizing. But that float is like a low water float. And what that is doing is you got 3 lines in there. And so it would work through electric, through that float with the 3 wires. And then it comes through to here. And it would make this thing, instead of getting water from these, it's like always getting water from over here. But if these tanks got low, then it would switch it to over here. So if this tank was full of water, and it just stays full of water, and it doesn't equal it, well, this would be open, but it wouldn't equalize because this Johnny valve would be selected to just send those 2 tank lines through it over to the pump. But I've got it decommissioned because we don't have a backup tank here. So I just have it to where the water's going everywhere through it. If you want water coming out here, you can open that valve and water will come out. Before it didn't do that, but I just didn't want it trying to move selections when you don't have a backup tank anyway. But if you want me to put another tank in here, I can easily do that. We can put that Johnny valve back into service. You can have those 2 tanks and this one getting filled up with rain, but this one not getting used, and if these 2 ever go low, then it automatically switches to that. But I don't like necessarily the automatic side of that, because then you don't know when it's switched back and forth, and I like to have a little bit of hand in that. Now we're going to go over here to the pump house. This is the last part of the equation. 2 different ways you could do irrigation system. I know your house is getting water from the city water here, and so this pump is strictly for, oh look at that, you got a leak. It's just a threaded connection. This is a union, so this is going to be very easy to fix. It looks like maybe they didn't put any thread sealant or something on there. So I'm going to close that off, relieve the pressure, undo this union, and then put some sealant tape on there and tighten it back up. But here's what happens, okay? Look, we got pressure. We're at 55 pounds. This doesn't have that arm on there. That's great. I've added this line here. So here's what happens. This box, that's got the 2 wires that go to the low water float. So it's always up like this. So I'm sending power. You got power going through here. I'm actually sending it back before going to the pressure switch. I'm sending the neutral, the common. Since this is 120, I don't even have power going in the tank. I'm just sending through this wire nut, I'm sending that neutral through that low water float. And then so it's going down there. It's going to that low water float, and then it's returning the signal and then coming back into here, and then it's re-landed here. So we got our neutrals here and our hots, and you can see that those contacts are open. A little space between the Kit Kat, or little, almost like watch batteries, the copper parts. When the pressure gets down, it's going to suck those together, and it's going to make that neutral connect and that 2 hots there connect, or the hot in and hot out, and that sends the 120 into here. This is just a junction box. It's not really a pressure switch, even though it is a pressure switch. We're not using it as a pressure switch, but that's how this pump came from the factory. But this is a better setup, doing it externally. And so now we've got it going into the pump, and it's holding pressure. Now this is closed. Your irrigation valve is leaking a little bit. I don't know enough about these check valves to know how to make that stop or not. But this is all open, but you do have a master valve here. So when this irrigation controller, which should be on now, yeah it is, when that is on and it starts running a program, every zone it opens, it's going to open that master valve and zone whatever. That valve, once that valve is open, this water then goes through, but for now it's pressurized and it just stops there. And so this might be just like a bad thing, or it might be normal. I couldn't tell you. I don't think that's normal. Anyway, you had this open when I got here. I closed it. Let's see what happens when I open it. Okay, water goes. You saw water pressure change with this, but it doesn't appear that the pressure is dropping, so that's probably to those hose bibs you have. You would know better than I do, and I don't know what that goes to. That might be to the open line under the deck. This might be to a previous pool feature. I don't know. Anyway, that's closed still. That's closed still, just like it was when I got here. You don't need any of that stuff. The guys were using that for test equipment. So it's ready for irrigating. And now the other way to do the system is without this pressure is just when the irrigation controller turns on, it runs the pump the whole time that the irrigation's on, and that's the only time it runs the pump. That's helpful, so if you have a leak, it's not going to keep running, or it's only going to run when the irrigation's on. But then sometimes you also don't know if you have a leak. So this is called a pressure start system. Otherwise, you only have pressure when the irrigation controller says let's go, and then it opens up a solenoid, and then everything starts running. So everything is running now. It's working the way it's supposed to. We've got the protections in place where they need to. I just need to fix that water leak, and hopefully you don't need me for another half a decade or more. I mean, unless you want that tank, I can get that here anytime. All right, thanks for watching. Hope that helps out in YouTube world. If this is something that you've struggled with, what's a pressure start irrigation system versus just without the tank? I can explain that more in another video. I probably will. I don't have one on my site yet, But send me a comment and I'll add it right away. Otherwise, I'll just add it when I come across the system. And otherwise, Mac, this is your system up here in Dripping Springs, and it's all working great now. You can run your irrigation, your grass is going to stop dying, and the well is going to fill those tanks until the rainwater fills it. If the rain happens and it keeps that float up, and that float is in that top third of the tank, as long as that float is up, the well will not turn on. But as soon as you don't have rainwater, or you use all that rainwater and it's not raining again yet, the float kicks down, like in my other video, and then the well will fill it up until it tops off. So it's always going to get topped off by the well when you don't have rainwater or you use it all. So that's how your system works. That's how it's supposed to work. And those are the things that I did to get it working. Was I added a relay, replaced that fill float switch, the pump up float switch, and then I ohmed out these wires to figure out what wires came from and went to where, and it took us a couple hours, but got it all handled. We'll get this water leak and I'll be all out of here. Thanks for the work and thanks for watching.